it the other way. But it's also not the challenge in Nangu when I did this assignment, but I can't draw a decision tree. Not decision tree from my knowledge because I come from a statistics background. Not a decision tree. I would now see my values, my values in my numeric values. So ndakachinja some of my fields and ndakangochoose all, but ndandisina kufunga kuti taikwanisa kushandisa principal component analysis to reduce those ones kuti wozosara nemafactors ari kuexplaina malikes ari kudiwapo. So for example, one would choose a like kuti ndinoda kana kuti like toti isusu handikuona kuti pamalikes panapa taigona kuti munhu aigona kuchoose sport handiti totobva tati sport yedu ndo yave y the predicted value. Then we reduce our features, which is gender, marital status, age, and so on. And not which feature is best describing the like sport. And one of which instead of kunyora for loop and akanyora akawanda asingare chino takushandisa chakaitwa nadhoni zero chekuti inonzi chiya encoder inonzi chiya yakaiswa nezero LE something.
Yes, the label encode.
Taisa everywhere pane manumeric kuti wane manumeric values edu. Taona manumeric values edu ini nditori necode yandakanyora yakatoburitsa decision tree, which means handaisafanira kunyora all those if statements kuti if it is male in under gender then it is going to do this and this and this. Urozvona.
But pama likes up, how then
assignment.
I see some assignment my encoder tasati akumaziya isu takatoshandisa ma-if statement.
Okay.
Kana imakashandisa maencoder mamutori kumberi. Ndimo vanhu vataitobvunzwa kuti tibatsireiwo kuti tipindure mibvunzo but mamusingabudikire mabuda nhasi.
Taurai. Yes. Ahora chainzwa inyaya yakanaka. I think kuti like you invited colleagues kuti you have a time to look into it. It's good, especially given that these courses led us or given us some light. I think it's a very good idea. Then nyara dzanobva yobaatiratidza izvo zvaakanyatsoita then tobata benefita tese. I think that would be fine.
But I think hazvina kushayiwa mugroup here. I think I saw someone akatoshare that information in our group.
Saka nyaradzo ukandiwanirawo wotikandirawo kati tinyatsoone zvapadhuze machatsi akawandisa pana akazoya ebhora nemamwe akazoya emavidhiyo ataiona pamalessons saka wozotipawo.
Let me check. I don't know, but I think someone really sent something. Let me check.
Senderawo tiite idea. Chiri mudondo.
I've shared something on the group which I think we used for that question of features. Yangaisha some encoders, I think.
Okay, ndaona mgroup arikatuzoiona.
Ko revision yacho ichaitwa zvayo here na lecturer wacho chai.
Manaenda muchifarira kungotaura zvinhu zvinotsamwisa vadzidzisi vedu.
It's a genuine question. Tichaita revision here and quit. Any answer will do.
Ndanangokorekta part yange yazonzi chaiye iyo ndio inotsamwisa vamwe.
Hi guys.
Yes, Don, we are here.
All right, I'm back. Where is it? Where is it? Okay. Where's the notebook? Where's the notebook? Where's the notebook? I guess I have to create a new one. Sarapa. Guess I'll just create a new notebook. Tab. Untitled. Oh. Can you see my screen?
Yes, Don.
Okay. Yes, I'll work with this. Select model. So far, Shandaita, I don't even have to explain Takusi. Was it salaries or salaries? Salary. Listen, I like putting my inputs angu esek soro. Okay, sorry about that, guys. I am. So this is the data set Ratingatinaro. We worked with no missing values. Okay. So categorical columns equals to df dot select types. I need to specify select columns. I cut only occurring to me that I did not import or initialize the labeling code.
I don't.
Yes.
So if you don't initialize the label encoder, it doesn't work.
Yes, I have to initialize it.
Oh, okay.
As I said, oh, okay. Okay.
I don't.
I
So initializing the label encoder is like creating an instance of the label encoder class.
label. Yes.
Okay.
So discipline 01 service PhD sexes. So rank has 3 items. Was thinking of one word encoding rank, but anyway, for the purposes of this one, we'll scale our data.
Sorry, Don, could you please go back to like that first line? I want to copy the last code you added.
Pre-processing, import label encoder, then comma, min-max scaler. All of these are imported from this. X equals to.
Hello, sir. Are you able to copy the codes in the chat box? I think about Saturday, so to follow up to be good.
Which one would you like? My imports here or?
For me, it's the lot after the imports. I think from line 5.
Okay.
Someone else wants imports.
Then this one was simply checking for missing values. So you're saying this one, Leslie?
Yes. Yeah, 5. That one. Thank you.
Is now and dot sum.
Okay. PF is now. Thanks.
All right.
Hi, John. What are we supposed to do?
On what?
On what we are doing?
Okay. Trugushik.
Okay, so in the meantime, what am I supposed to do?
Are you typing? I thought we were like typing along.
Well, I wasn't. Maybe I guess I should now.
Okay. I'm going to upload though this one as soon as tichifika patuda kusvika. I might as well also input the PCA mukati momo.
Kindly go back to like line 9, sir.
Okay.
Hi, John.
Hi.
So, Jananchi Bunza, I mean, for example, Abu Patati DI online number 9. Patati Susu for I in cut DFI is equivalent to LE. In place of LE, if I write label encoder like that, dot fit transform.
It will only work after you've initialized label encoder. Wakati label encoder equals to label encoder, when we initialize like this. The encoder dot fit transform, yeah, it will work. Also, I'm going to tora label encoder to go tangana dot fit transform. It will not work. It will throw an error.
Okay.
Saka ndobva ndangomshoti napa kuinitialize. Ndine nungo dzekutaipa.
Sorry, Don. Can someone please share the file salaries in our group for those who have the file?
Patkaita EDA with pandas. If you remember, that's the file. So if you have that notebook, EDA with pandas, if you create a new notebook in the folder in your EDA with pandas, it should run because it's the exact same file. More classroom folder akanzi, yeah. Pandas.
Sorry, John. Mine is giving me an error saying What is it? LE is not defined. Line 9.
Did you first define LE session data app? LE is equals to label encoder in my parentheses.
Let me see. Oh no, I had not done that.
Okay.
Okay, thank
You're welcome.
Can you scroll upwards a bit?
My cells are up higher. They did not necessarily affect my mirror a data frame. They're checking it. Ekuti wakawarana, they affect mabudiro aro. Takatangana cut, whereby we're creating a list of columns with an object data type. Then upper, when we're label encoding them, teacher will transfer to columns with a numeric data type. Are we all together now?
Yes, yeah, you can now scroll down. It's okay, thank you.
Okay. So in this particular instance, we just so skills goes to okay.
Hello, sir.
Hello.
Say night, I'm failing even to read the CSV. I'm not sure where am I lost.
Right. Notebook rako war open ram folder ripi.
I just created a new notebook.
Jeremiah, you can also check our salaries CSV file that we added the capital S. So probably you may need to change on your code.
No, I actually copied the name of the file. I have it on my folder, in the folder, and I can name out machine learning. So I actually copied the name.
Navigate your Jupyter notebook. Uyende mu folder rakanzi machine learning. Or create a new notebook in there.
Okay, thank you, sir.
All right.
Sorry, sir, for asking, Zinuzo. Would you probably have explained a couple of times, but there's no. Abamati x is equal to df.log. Then Vomazo says brackets. What does that log really mean?
I'm locating using the label. So when I'm slicing a data frame, there are two ways. I can use ilog or I can use log. If I use ilog, I use an index locator. If I use log, I use a label locator. I locate the particular items and Rukuna based on the label. So when I'm slicing like this, it's rows and columns. Rows, comma, columns. So rows, I just put this, meaning everything, comma, columns from here, colon up to here. This is the range.
Oh, I get it now. Thank you.
Oh, you're welcome. Oh, so it wanted to make Y a two-dimensional data set. Anyhow,
I don't. Why Yaramba to apply transform on that Y series?
nenye kuti initially Y anga asina ningrekeni. It was just one-dimensional. Saka apa, I have to change Y. Kuti ave kind of like two-dimensional. Ndo pachipandinomitira reshape. So when I say dot values, I was changing Y to an array, numpy array. Then a numpy array in this, the reshape. Then it's now well, where can I put it? Whereby wakada kuchitarisa our Y after this. It's now just one row. Pekutanga papai, it was one column and many rows. Saka izvezvi uri kuona kuti how it now appears. It's now just row renhingiriki, one row. So I had to change it to this format kuitira kuti igone apply the transformation.
Okay.
Estimator, which estimator are we going to be using? Regression. I don't remember. Am I supposed to initialize linear regression first? Kana kuti inokona kungorovera imomo. Linear regression. The estimator threshold. Importance getter. So what select from model does is it's going to select features based on my coefficients at tapiwa nechi ne model. Parameters, normalize. My My bad. I'm supposed to use last one in this instance. Last one. I thought that linear regression will give me a chance to input the penalty as last. I guess local option than I ever die. Hello? Motion. Hello? Yeah, sorry about that. Hey. I'll put it out on my $78 to 1. Okay, no. My importance get order. No, dots.
Mukuru muko nokwira bijana kumsoro.
Okay.
Sorry, just hold on, Baba.
Okay.
Hi, Don.
Hello.
I didn't quite get the use of select from model.
Okay. It's sort of like it's a repo which gives us my coefficients. Okay. Let me give you. Where is it? Good. Now, assuming I'm not using select from model, right?
Yes.
Okay. Then ndinenge ndisagone kushandisa na get support. I would have to go for coef. So apparently lasso regression yadzora maningi edu ese to 0.
Okay.
All our coefficients. Saka iri kuti none of them are significant. Saka I have to find a numeric data set. Ainogona kuningira. But handoona yaya yapi yatibuditsira false.
False. Yes.
Yeah. So what it does is inobva kuratidza all the indices of my values anenge areduced to 0. Saka those features ndo anenge achitreatwa as unimportant.
Okay, so it's like it's like a linear regression and we are getting the coefficient.
Exactly. So when you use lasso, called what? It's an L polarization. So what it does is it punishes unimportant features by reducing their coefficients to 0.
Okay.
Then important features, it increases their coefficients. So how it then works is
I don't.
Hi.
Sorry, I'm still getting an error on scaling the y variable.
Okay. This is what I then before scaling. Okay, on scaling, you then put your reshape y into this format. Y is equals to this.
Hi, Don. I think all our coefficients have 0 values because the y, our label has also all the values have been reduced to 0.
Yes, that's
For
also
our
what
Y
I'm
scale,
seeing from my end.
Oh,
yes, all the label, like all of them are 0.
The
All the
scaled
values are 0.
ah, nice. Good observation. Nanchitoshamisika why yadaro. So, we reduce everything to 0. So let me try to address this by calling this. I'll use a standard scalar instead. And wait. I'll use a standard scalar. Wait. How can y scaled still be 0? Okay. Wait. Okay. Ah, yeah. Scale.fit underscore. Why akamira kadai? So I'm guessing pari shape yangu up. Let me restart my kernel. I'm guessing it pari shape. Restart and clear output. Okay. Okay, let's see. Where am I getting the error? Oh, yakuchikanganisika pana y dot values. Why? When I then look at y scaled, I should be able to work with this. Still giving me the same output. Cell.fit. Saka iri kutadza kuisa kuassigna y to the proper item. Nanas. So according to this, it's saying none of our features have any relation. So to fix that, instead of label in quarter, I'll go for a one hot encoding.
Hi, Don.
I
I tried without scaling the Y, without scaling the label. Then it's giving, and I used lasso without the select model.
model.
Yes, and I used the SEL dot coefficient, but it's giving me like the coefficients are very large, like
Yes.
24,000.
Are all the coefficients large?
Yes, they are all very large.
Data. Okay. Yeah, not when we scale it reduces to 0. Saka macoefficient anofanira vachibuda.
Okay.
However, the deal with this one is okay. Assuming we do it this way, right? We remove the scaling. Assuming we remove the scaling, what you then want to do is good. Above. What you would then want to do is I'll just call this T. Right. T series is equals to PD dot okay then.
I don't.
Yes, I.
After this, after the code is successful, please, we request you to take us step by step from the moment when we started scaling. We are lost.
Okay, don't worry about it.
Thank you, Tom.
So basically, it's not about.
Michael, can you please mute your mic? Michael Taonga, please mute your mic.
It's not about the size of the coefficients. It's about basically, okay, Toku header. There we go. It's not about the size of the coefficients, Toku Truba. There we go. It's about choosing which are the important features. So X has 5 labels. And in the end, you can see how important each one is. When you then visualize the coefficients, that's how lasso regression is used. Meaning, if I am to do a df dot head, can you see? Rank is important, followed by discipline. And PhD, not so much. Lastly is gender, 0, 1, 2, 3, 4, which are our variables. So can you see how lasso regression is used? Challenge is when I then scale them, so close to 0, my coefficients are such that when we try to view them, it's going to be the accuracy, the precision out, like putting this is 0.005, this is this. It's just producing zeros, which is a challenge scaling. But anyway, Let us go through it. Ditsananguri. Restart and clear output. Right. So, okay. Import, right. Whether we use select models or not, it's sort of like what lasso regression does. Okay. Since we did not scale, we just fitted this. Right. So what lasso does, as I said, it punishes unimportant variables by giving them a coefficient of 0 or at least close to 0. And it promotes important variables by giving them a coefficient which is quite high. So it then shows you which are the important variables in your data set. So let's assume you have maybe 50 columns in your X, the independent, in your predictor variables. You have 50 columns. If you pull off lasso, you can then choose a threshold. Yekuti aiwa, starting ndungoda zvino zvinongosvika pamwe with a coefficient greater than this. The rest you drop them out. So that's how lasso will work in simple terms. Then
so now the question would be, how do we I saw you wanted to use the standard scale. How do we get the appreciation of which one to use under what circumstances?
Min-max scalar reduces to a range of 0 and 1. Standard scalar, it's I think -1 and 1 ordinarily. So standard scalar gives you a wider range. So you use standard scalar if the range in your variables, maybe you have a 2 over there and you have 1,000 over there. If the range is that big, you can use standard scalar. If for dealing, maybe our variables are around 20 to the hundreds, you can use min-max scalar. It is arbitrary, but min-max scalar is when there is not much difference, and standard scalar when there is a big difference.
Please scroll up to where you were defining y.
Pardon?
Kindly scroll up to just.
Okay, y is just df salary. Y simply refers to this column.
Yeah, I want to copy from there. Thank you.
Okay.
John, are you able to share the notebook?
Okay. So can you see how you can then use lasso regression to choose your variables for in your feature selection? Oh, wasn't a mic.
Hello, Don.
Hi.
So is there a moment where probably if you use the both methods, like the principal component analysis, and then you use the lasso, the regression, and you get to a conclusion that is different from either one of the methods? Because I see now we have agreed with what we have done yesterday, that the rank explains more towards the salary, followed by what did we say? Followed by
Well, with principal component analysis, it's hard to tell which exactly contributes more, because what it does is it just reduces the dimension of the variables. So when the dimension has been reduced, its output, it calls them factors. So what it does is it gives you how many factors or which factors explain the variance the most. So it's hard to interpret PCA in terms of which one is the most important. Because you can have a PCA and reduce dimensions from like 50 to 20 in one go. It will give you that out of the 20 you have reduced, the 20 dimensions you have highlighted, only 4 contributes 90% or 80%.
yes.
So you know what is exactly contained in those 4. It could be a bit of each one, so it's kind of hard. On the other hand, this one shows you which variable is of importance, lasso regression. That's why I then mentioned it yesterday when answering the question of how do you see which one is important. Principal component, you just transform them and you just load them into the model in that PCA transformed state. Then lasso regression, I run my lasso, I now know my important model, my important variables, 1, 2, 3. Then now just like, okay, Saka, when I now load into my actual model, I'll then only include this. I could leave this one out. No.
Interesting. Sorry, Don, maybe just to take you back, is there any point of conversion between the lasso method and the PCA, or they run in conflict?
Conversion. Well, what you'll be trying to do with your lasso, what you'll be trying to do with your is reduce the features, is reduce the dimensions of your model, reduce the number of features. So how it exactly works is like it kind of takes like highly correlated features, kind of places them as one, etc. So the factors in a PCA may not exactly contain only one feature. Unge factor 0 may not only contain ring. That's what I'm trying to say. So yes, you can use lasso, not are important in the app. Then you can then transform a lasso with PCA. Then you can then load them into your model.
I don't.
Yes. Yes.
Sorry, Amang. We are just trying to understand these concepts. So from my background of statistics, if I employ PCA, what ideally I'm doing is to reduce the number of variables that I want to remain with those that explain the most on the predicted value. And so now I have these new variables, and ndaona kuti okay mafactors angu andabatanidza or whatever, maybe from 10 now ndasara ne 3 factors. From the 3 factors ndopauri kuti wewe you don't know which is which. Aita kuti uzoti these 3 factors ndo ari kucontribute more in terms of variance explanation. So my question, so my question would be, okay, taziya kuti tine 3 factors using the PCA. How is it really helping us in terms of building our model? If kana isusu tisiri kukwanisa kuti identify kuti from the 20 variables from the 10 variables that tatanga tinadzo, which one of the 10 variables is important in terms of predicting our value, the predicted value?
How I normally use PCA. Dinozo is I load the transformed variables like that. For instance, the example I was showing you there, I had realized some of my variables angari mumboto and I ran had a multi-collinearity effect. So I used the PCA transformation to address that.
Hi, Taurai.
Yes.
Hi.
Maybe if I can come in, I think he's asking the same question which I asked yesterday. So from what I got, Taurai, I don't know. You also tell us from your point of your experience. From what I understood about PCA, it's kind of like compressing our data from a higher dimensional space to a lower dimensional space, whereby probably we initially had like 10 variables, right? And after running the PCA will give you an output of variables. Probably it will compress something like that, like compressing those variables into probably like 4 variables, which are actually different from the initial variables. So you are now working with the new output of the PCA to actually model, to predict your variable that you are trying to analyze.
Exactly.
Yes, Farai, that one I understand. Because now
then on the issue of trying to understand which variables are actually are significant in terms of predicting our Y variable, that's where Don said we now go ahead and use lasso regression to actually see which one now which of these variables are statistically significant in terms of predicting our Y variable.
Yes, yes, Farai. And we're actually saying the same thing.
Yes.
Maybe if I repeat it and if I'm saying it differently, you can correct me. Taisa PCA reduce some factors ma variables eluba ku 10 kusvika ku 3. But 3 atasara now aya tisi tichatomapa mamwe mazita kuti probably first variable will then say location of the house. Then variable number 2 tobva tazoinyora kuti kana kuti number of rooms. Then variable number 3 tobva tanyora kuti is it walled or chi. But mukati umu but let's say patati house location of the house. Zvaitaurwa nadhoku zhazha kuti tenge takuona kuti the location of the house might be red, might be whatever. Pane tumwe factors tokubatanidzwa kuti tizoti the location of the house. And so isusu tazokubatanidza aya tikagadzira a new variable yatiri kuti chi, a new factor yatiri kuti the location iri kuita comprise of these subunits that are building to that. Saka isusu now my question is, isusu kana tichida kuzonoemploya the lasso regression tichinyatsoziva kuti out of the 10 tichida kusara kana kuti let's say nenumber nekuti is it from low density or high density to predict the value of the house handitika tisina kumabatanidza sezvataita kuPCA. My question would be, why are we even doing the PCA isusu tikwanisa kungoita lasso direct and get the actual variables that are contributing more or that are important mumodel medu isusu? That was my question.
And to answer you, ndakudza ndakati, when I used PCA, it was not to see which one is important. Some of the variables had a multicollinearity effect. And the model I was running, the assumption that effect should not exist. So upon kashandisa PCA and they were compressed, that effect was addressed. Dovandayata say, my model's performance improved. So PCA, I was going to see what is important. We're going to transform in areas where the transformation of often a PCA is necessary for your model. Remember, feature engineering, it's not only feature selection. It is giving your model quality data. Trying to present your data in a way which is best understood by the model.
Yeah, apa ndazozvibata manje. Now maybe I had missed your first attempt to answer me, but right now tamugwara manje.
All right. I think Doc should be coming now one. Then Pareka Indishida. So, oh, I'm still sharing.
Say, I hope you're going to share with us that file, because Tasara Masure Bijana. Thanks, thank you so much.
Ndoipa yakadai so kana ndoisa ngrekeni. Select from model. Would you want it this way, or I should include a select from model? Morguida in a select from model feature. Which way do you like it, simpler or long? The notebook.
Simpler, say. The simpler one.
All right. All right. In that particular instance,
is it possible to include notes per notebook?
Very. But se vanhu vakakateerera munogona kuzongoaisawo.
Tasara Mashure.
Makamasara mashure musiri kukodha. Makasara mashure musiri kuteerera.
Tichikoda tiwana maerror saka.
Okay.
And kuti tozoita go through, at least follow with comments.
Maereka ndingonyora.
Can't we have a break while list? You're sorting your notebook
Yeah,
so that when doc
yeah.
comes, one we are fresh.
Okay, feel free. Consider yourselves on a break. Since we did not get to scale, I'll remove this.
Hi, Don.
Hi.
If we use select from model and after using the get support function and we get true, 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 how do we then deduce which features are which features are important?
Um,
Because giving me
okay, the get from select from model function. When I use the get support, inongondiudza kuti which features were actually selected. It's used kana data set rakakura, maybe rine something like 50 features. I cannot visualize them. Maitiro andaita aya ebari 5. Saka inonoritena a false pasiri and a true panenge pane feature exist. So what I then do is ndinobva ndango slice a data frame using that index of false and true. Using that index of false and true. So if the data set is very large, yes, I purple select from auto. But if it's small like this, well, unongogona kuita wakadaro. Yes. So guys, I have uploaded the file. Then it's in the feature engineering folder in your Google Classroom. I also included the salaries dataset that I used.
Thank you, Don.
Okay. So at 1, if Doc doesn't show up, one of you call me. Then Dotsoka and I'll take you through the rest.
Hello guys, kana lesson yatanga mongotisira kamugroup murega timboseva data.
Yeah, quick question. What time will you guys reconvene?
Maybe one done.
All right.
Hello, team.
Hey, how are you?
Good. Is there anyone who can assist me? Which geopandas that does it charge? I need.
Okay, what's your problem? Hi, Sivo.
Okay, let me share. Because when I'm trying to install it, it's saying the requirement already satisfied. But when I'm now running it on my notebook, it's giving me errors.
Team, can you tell us in Maneri?
Right. Are you seeing my screen?
Yes, the font is too small for my side, to be honest. Okay. On the list. Sivo.
Okay. My network dropped the other time I was being assisted. As you can see, it's saying is already satisfied.
Can you type Conda list add? Type Conda list add.
Aaron, I type here. Right, it's giving me that list.
Can you see with the pandas were installed? Fine, you can just type Python. You want to import the GeoPandas. Just type Python.
Python here.
Yes.
Python.
Then import GeoPandas is anything.
Import GeoPandas. There is this last message.
How does it read? I can't see.
Saying win error 126, the specified module could not be found.
Okay, you could have installed your GeoPandas, but there's a library, the geo_c.dll could not be established. Ishmael, can you give him the link to download the that library, the missing library? Get it from Ishmael or Christy.
It's on Google.
Okay.
He knows that it's on Google, but the link.
I download from Google.
I'm going to Google to download the GeoSP, and I don't have the link offhand. The first hit nobody that link you can download the file.
So, you go on the Google, you download the file, you save it. It will be in a zipped folder. You extract it, then you paste it in that path.
Okay. All right. I'll come back when I'm having challenges.
Simbo ndakuisira chilink ndakuisira chidownload chacho pa WhatsApp.
English hapana patao.
Papa, you can't share files. I don't know. How do you share files here?
No, I don't
Yeah,
know.
because I've seen
What I did is
by some group.
But surprisingly, I'm going to get in the appraisal installer Joe Panda. So you know that was for something else, Footy.
Aiwa lesikana yako yakapedza yatobo.
Kunopedza kuinstalla kaukainstalla nepipi inenge isina that library iro rechiyo what unless twakainstalla
ndanchiteedzera zvamamuchitaura ndazoita nyanzi chiimport geopandas as gpd yaramba yati import code what
yeah inenge ine that missing my dependencies and like imboisa that file, the missing file, it should work.
Okay, thanks. Let me go per chat. Per iskwana. What's Tau?
Hi, is there any update from John on the lesson?
Oh, sorry, Tongai was already talking.
Not as yet. I'm still trying to get hold of Doc. He's not picking up his phone. So as soon as he picks up the phone, Doc, I'll update you.
Okay, and don't hang that if Doc is not available, we can call him and then we can continue.
Actually, I was speaking to Doc in the morning. It said he had some work to do, and he was going to join us like after lunch, like just after 1. So I just need confirmation on the extra time that is coming.
Hi, Taura.
Hello.
Are you in?
Hello.
Are you in? That's a rhetorical question.
Yes.
Okay, what did you say about the discussion group? What were your parting words or your final words?
I just said those who are interested, we can find time that is that is okay for all body. So I don't know, no one apart anyone who have come back with a time. So we just need to agree, and then we start it from there. I think it will be helpful for everyone.
Okay, is it like during the week or per weekend? Which is which?
Even if you say today I'm free, tomorrow I'm free. So it now depends.
For venue, what is the venue? Is the venue virtual or physical?
For what I was saying, I think we should just do it online. Then the other one, David. Where is David?
David is not yet on the platform.
Yeah, David was organizing something for us in terms of venues and stuff. I don't know how far is he with that.
Hi, Taurai. What I noticed is getting people to agree on time with a large number of people like this might be impossible. Why can't you just say date and time? The moment you do that, you realize people will start giving you alternative dates and time. So if we want us to do maybe tomorrow or Monday, we can just say Monday at 9 p.m. guys, revision, those who are interested. you realize that if some people join, some people request for a time change, and then we'll then come up with a plan from there.
Oh, I see. Sorry, someone is calling me. So I think I'll just I'll just put the time on the WhatsApp group, and then we take it from there. Time, date, and the link.
Yes, I think that's better, and then take it up from there, because I think that's a better approach to get things moving.
Okay.
Yes, Eve. Ngwanyarira tetariswa voice remutungamiri wedu.
Shamwari. Pakaiba, what do you say?
Ndiri bo.
Ndiri bo futhi.
Faraiwa kuita jealous hesako kabhani. Hapo Farai.
Hapo.
Ndandiri kutirega ndichingokumhoresawo sezvo ndapedza kumhoresa vanhu vane basa.
Ina ndina basa nekudiwa tsva.
Vana Eva.
Yabona makombetseni apa pamhuro here.
Yes, Fats. Mushe kufamba sei?
Pane ka black coffee. Sound kanisonga papa zvekufaya.
That's amazing. Anyone
who downloaded the Lasso.
Hi guys. Yeah, I've managed to install that pandas. Thank you.
Welcome. Thank you for the feedback. Hello team. Anyone who managed to download the last file that was uploaded, the last regression, I can. There are no comments, but he was putting comments. Did I download the right file? Anyone who downloaded the last regression?
Sorry, I'm also looking for that one.
It's on the teacher engineering in the class, Google class.
Yeah, it's not there. It's not there.
What's not there? The one with the comments.
It's there. Why does it?
Kuti mapandas angu anenge atoitera pageopandas.
Ishmael.
Hello, Tsungi, what?
No, okay, I'm saying no better Tindarishaya. I got it, but I remember comments. The last time I remember it was putting some comments.
Ishmael.
Blessing akaisa mic yake on saka mese pamurutara hazvisikunyatsonzikwa.
Oh, sorry. Apa ndainstalla geopandas saka pakuzoti import paper kudisa so ine zvinenge zvatoita here because ndikuona pekupedzisira pakanzi file not found error.
It must be a GL uri kushaigwa rere. Cheka kuti rakanzi chii full file name racho risiri not found.
All right, minute one.
Can you
Ishmael, did you get my concern?
Yes, I'm seeing it in the chat box. I hadn't checked. Let me just check.
Hi guys.
Yes, Don, how are you?
I'm good. Has anyone heard from Doc?
I was trying to call him, but he's not picking up his phone. I've also sent him some WhatsApp messages. He has not responded yet.
Oh, kuti kangova manheru wakomana. What's the time there?
You can take us through.
Okay. Do I even have the materials on hand? Okay, let me just hold on as I check if I have what he wanted to present on at hand. Okay. Okay. So what you're going to look at today are machine learning metrics, which the KPIs we can use for evaluating our model performance. So from your step, I'm sure you've already looked at used for evaluating, your linear regression models, right? Richardson. Hi guys. Okay. Right. I was saying from your statistical analysis, you are aware of the various metrics to evaluate your model. I'm not sure this aspect. You use the mean squared error, the root mean squared error. So for this one, I'll focus on what I know you definitely have not covered. So I'll be focusing on the metrics for evaluating the performance of a classification model. A model which predicts which category or class an instance belongs to. So, our agenda will be focused on these 5. We have accuracy, precision, F1 score, and the confusion matrix. So metrics help capture a business goal into a quantitative target. Right? So it's useful to identify the gap between desired performance and estimate effort initially. Desired performance and current performance. So it measures progress over time, the no free lunch theorem. So what I would like us to do, consider a model which predicts, which classifies, a classification algorithm, which classifies dogs or cats. So true positives are those instances when the model predicts that a particular instance is a dog when it actually is a dog. That is a true positive, right? Then, because the way you look at this is dog is 1, cat is 0. This is a binary classification challenge. So true positives are the classes the model correctly predicted as 1, which is the dogs. We can look at if it's a cancer issue, if the model is predicting whether a particular cell or someone has cancer or not. 1 becomes has cancer, true, not 0, does not have cancer. So true positives are those observations in which the model correctly predicts that this instance belongs to class 1. True negatives are those instances when the model correctly predicts that this particular instance belongs to class 0, or in our case, belongs to the cat class. So those are true negatives. Are we together on this one so far?
Yes, Don, we are together.
Okay.
Yes,
Somebody
Don.
not want to try.
Maybe you could also share these slides after the lecture because the other ones you have not yet shared.
Ndakatowashaya kwandiri saka mamwe ayo munotozoona. I think kuna dog. These ones let's see. Where is our classroom? Okay. What's the name of this class? I'm creating a new folder titled Machine Learning Metrics, in which okay, done. I shared this. So, false positives are those instances when our model predicts that this is a dog when it actually is a cat, or predicts that this person has cancer when the person does not. That is a false positive. So a false positive is an incorrect prediction of the one class. A false negative, it's when the actual class is a dog, but it's predicted as a cat. Using a cancer example, when someone is said not to have cancer when that person actually has cancer, that's a false negative. Right. Then this is now the confusion matrix. On the Y label, we have the actual class. On the X label, we have the predicted class. So it then becomes like this: dog, cat. So the actual class here, if it's a dog and is predicted as a dog, that's a true positive. If it's a cat here and is predicted as a cat here, that's a true negative. Then if it's a cat in actual but predicted as a dog, that's a false positive. If it's a cat, if it's a dog in actual but predicted as a cat, that's a false negative. So when you are reading your confusion matrix, your confusion matrix, the correctly predicted variables are diagonal like this. Can you see this? So even if it's many classes, you look from the top diagonally to the bottom right, you will find the correct predictions. So this is for an instance where there are two classes. And so having done this, you now understand what we mean by true positives, true negatives, false positives, false negatives, right? Class.
Yes, Don. Yeah, it's. I think it's clear.
Okay. So.
Sorry, Doc.
Yes.
Yeah. Okay. I wanted to try and understand maybe on when the class is a cat, and now when the prediction is a true negative. Maybe in terms of understanding that, that's what I need to get. I didn't get it there.
The actual class is a cat. The predicted class is a cat. That's a true negative. So, okay.
How is it negative when it's a cat that has been predicted?
And also,
Okay.
how is it different from a true positive?
Okay.
I don't.
Okay,
I think zvinonzwisisika mishanisa zvecancer izvezvi apa
okay.
pamadog nemacancer
All right. Rega ndoshandisa zvinonzwisiswa nemunhu wese. Ndakushandisa zvenhumbu. This is a pregnancy test. If it predicts 1, you are pregnant. If it predicts 0, you are not pregnant. So, true positive is when the model predicts you're pregnant when you are in fact pregnant. A true negative is when a model predicts you are not pregnant when you are actually not pregnant. That's what a true negative is. A false positive ndetsatsa zvinorowesa mabhachura nehana dzekuti zvonzi ane nhumbu iye asina. And the false negative, when the test says you are not pregnant when you actually are. So the reason panapa ichinzi true positive, true negative, the way the model predicts is it's either something is a dog or is not a dog. Right. 0 or 1. True or false.
Sorry, no. So pakanzi keta apo togona kuti not a dog.
Exactly.
Okay.
Zvinenge zvakunzwisisika ka?
Yeah, zvakadaro zvinonzwisisika.
Yeah. So negative, it's inobuda pakuti whether an instance exists or not. Remember, tinenge taita integer encoding yedu. Yatipa 0 and 1. 1 is for true. 0 is for the negative. 1 is for the positive. 0 is for the negative. So depend whatever you are predicting, chincha asainirwa 0 is now treated as the negative. Chincha asainirwa 1 is treated as the positive. Paunoitayo integer encoding paya. So, accuracy, it simply refers to all the correct predictions a model over the total predictions on a model. So the correct predictions are true positives and true negatives, right? Then the total predictions on a model, true positive, false negative, false positive, true negative, all that, the sum of all that. So this is what it is. All the correct predictions, true positives plus true negatives, divided by true positives plus false negatives plus true negatives. Are we together on accuracy?
Yeah, it's quite clear.
I don't.
Aye.
So on accuracy, we would then say that is a probability.
Not a probability per se. Accuracy, we're evaluating how well did the model do. Out of the 100 predictions it predicted 80 correctly. So it then becomes 80 over 100. So we can now say the model is an accuracy of 80% or is 80% accurate.
Sorry, are we able to say, for example, say 80% confidence level to interpret the model and say 80% confidence level?
When we're looking at significance level, it is a F1 score.
Okay.
Yeah, it's another metric variable. But accuracy is just that. How accurate is the model? Iri kugona kunonga ma prediction zvakadii.
So Don, is there an acceptable range of accuracy, or it's just good the lower it is just shows good the model is not appropriate for it?
I believe the acceptable accuracy range depends on a few things. I guess it depends on what model yechi. You see, if I'm doing a customer segmentation model and I get an accuracy of 95%, well, I would consider that good. But if I'm doing, let's say, a model, it predicts maybe whether one is pregnant or not, or whether one has COVID or not. If it's 95% accuracy, it means per 100, 5 will be incorrectly predicted. Kanawa 1,000, 50. Kanawa 10,500. Kanawa wakat. So if it's a life or death situation, the stakes are higher and accuracy needs to be higher. If it's an issue of insights, then I think you can go with 95% being acceptable. It's arbitrary. It depends on the use case of the model. That's all I'm trying to say. Answered?
Yes, Don. Thanks.
Okay. So
I don't.
Hi.
So in the event that your accuracy is not up to, let's say, to the decided accuracy, whether the researcher or whoever is doing the model, you to correct that so that you have a better accuracy. It means that you are now going back to feature selection. Want to improve, or how does one do that to improve the accuracy of the model?
As we are building models, we'll deal with non hyperparameter tuning. You can use Shinengana grid search, whereby, you see, when it comes to model performance, there are those little nuances which, when you tune, they improve the performance of your model, or they can actually make it worse. For instance, I can change the number of neurons on my deep neural network model. I can change the activation function. I can fine tune the model, and it can improve accuracy. I can go back and work on my feature engineering. It can. Actually, there is this manual way of feature selection whereby one runs the model with all the variables inside. They know PISA one on whether the accuracy improves or not. If it does not, if it reduces, then also that variable is important. You have to check it. I know PISA another one, a different one, etc. Then you can actually tune the parameters of the model, the number of epochs or the number of iterations it's supposed to run, the learning rate, various things we'll all look at. Then I'll find out what I mean by that, and I may end up confusing you more. But yes, if the accuracy is not up to standards, yes, there are techniques you can implement to improve model performance. Are you answered?
Yes, thank you.
Okay. Then precision, right? This is the ratio of correctly predicted observations to the total predicted positive observations. This is what we call precision. Kutirungotarisa only the positive aspects of my prediction. Then so if a model is precise, so on a precision, I guess you can think of them as being used in the, okay, let's look at in the health sector. Let's look at the COVID pandemic. We understand that our model may not be 100% accurate, but to curb kufamba kwechirwere, you can now look at model yatachoose. If it has high precision, it means that painenge yati munhu yari positive, munhu, there are very high chances kuti ano atori nayo COVID. When we then look at recall or sensitivity, it's the ratio of correctly predictive positive observations to all observations in the actual class. Saka recall, takuchiti out of my actual predictions adoko, mangani ayagona kutora. So if a model has a very high sensitivity, there is a chance kuti, if sensitivity is like 100%, there is a chance kuti inononga everything in that particular instance. Kuti ayo this is positive, this is positive. So it means kuti a model with a high sensitivity would mean kuti even though it may not be very accurate, asi haisi munhu ane COVID achipfuura. Inganyepe kuti uyane COVID iyasina, asi kashoma kuti nyepe kuti hana COVID iyainayo. That's how those metrics, those are instances where those metrics can be applicable. Okay, in banking sector, you are aware of the issue of maybe credit card fraud. So, if I am to do a model yangu, you identify whether a transaction is fraudulent or not. Wakanotarisa kuti in most data sets akadaro, munhu usati wazorohwa chekuseri, unenge waita 1,000 transactions and chekuseri unongochirohwa ka1. So the data set is usually highly skewed. Maybe only 1% of the transactions are actually fraudulent, and the 99%. So that model inongono predict out ese asi fraudulent. Inotoita 99% accuracy. But isusu havisiri izvo zvatirikuda. Tirikuda kuti model yedu igone kunhonga as the transaction is being performed kuti hamai apa pari kurohwa chekuseri, and it stops. So if the model then has high sensitivity, it would mean kuti even though transaction here is still fraudulent, it could be flagged as fraudulent. Munongo is an authentication code. However, haisi kuzosiya munhu a fraudulent transaction ichipfuura ichiti ayo iripo iyo isiri. So that's those are the instances you can think of where you can now apply the importance of precision and recall of accuracy. Then we have the F1 score.
Hello, Don.
Hello.
So can it be safe to say the precision is the same as the recall?
No.
I'm seeing on the formula seems like they are the same.
This one only has false, has only positives. This one includes a false negative on the last value. Recall.
Thank you.
So sort of like precision, it kind of looks at model yedu pama positive ayagona kunonga. The positives it picked up aya predictor how many were actually true. That's what precision looks at. Then recall or sensitivity says out of the total positives are in data set, or out of the total positives are in data set, how many observations were the model was the model able to accurately pick? Similar but different. Include false negatives, whereby this false negative, they could see the model predicts that this is a cat when it actually is a dog. So that this is a dog. Then upper false positive, the model predicts that this is a dog when it actually is a cat. So that's the difference, the FP and FN in recall and sensitivity. So the F1 score is the weighted average of precision and recall. That's the formula. And the F1 score, it gives us the significance of the model. So don't have to draw on this. Mario Nagandari upload. Then this is the confusion matrix. Okay, questions and answers. Q&A session. Are there any questions regarding machine learning metrics?
I don't.
Hi.
So let's say if I have 3 conditions that I want to put into that confusion matrix.
Mm-hmm.
How will it look like? Because from having a two class structure, it is pretty much straightforward.
Okay. I understand. Okay. Okay, where am I sharing? Presenting, stop presenting. This is for a model I was creating at work. This is how it looks like. So I had 4 classes, as you can see. So these are the predicted, and on this axis we have the actual classes. So 0 predicted as 0 is there. 1 predicted as 1 is there. As I told you, you just look at it diagonally like this.
Okay, so those ones who are more diagonal line, as you are indicating, those are the true positives.
Yes, those are the true positives and true negatives.
Okay, so the first one, Pana 17630, where 0 is where class 0 was predicted as 0. That's a true positive.
Yes.
The next one, Apopoga case of your mouse, that is a true
How can I explain this in a way I'm ningem chance we see some? In multi-class, panoshanda as a functioning on softmax. You put predicts out data here. There is a probability a cat could it belongs to this class, probability a cat it belongs to this class, etc. Then you not track at the class with the highest probability and it chooses. And it chooses. Saka in those terms, oh wait. In those instances, okay, so that this is my matrix and for the model I then worked on, which was multi-classification. So the precision for each class, the recall for each class, the F1 score for each class, then you want accuracy here. Then you panapa the average for precision and recall. This is called a classification report. This is called a classification report.
John,
yes.
Quick scroll upwards. Yeah, there. My question was really to understand which kind of values they do as one that my classes they does one that for part 2. Like we have rightly said, the first position up 17636 up. That's a true positive. Can I talk to up as a spot you how do you know this is a true negative or a true positive? In what relationship?
Okay.
Now, yes.
As I was saying, in multi-classification, what it looks at is whether class mono, how was it predicted? So for each class, I showed you could the precision and the item for each class. So each class is treated as a positive. In a negative sign.
Admire, mute your mic. Okay, you may continue then.
I was saying each class is treated as a positive on its own. So I notice that more class this prediction in year 1. This positive, right? Whereby it would that this was 0. That's the correct prediction, yeah, 0. The rest are along this 0. These you can call them false positives. It's not necessarily about the terminology on what you call them. I think various texts will call them various things.
Okay.
There is no universal. So rather than focusing on the terminology of what then we call this, it's about the concept here. What was correctly predicted, what was not. So no calculator and I recall. It's nana precision. It does that looking at each and every class. Each class is a positive. So yeah, I guess. Are there any other questions?
I don't.
Aye.
Would I be correct if I assume that false negatives constitute part of the positive set? If we were to plot maybe just the positive set and the negative set, for the positive would get true positives and false negatives to constitute the positive set, like based on the recall formula.
Yes, false negatives constitute the positive set. What happens is, if it's a false negative, it means it's actually a positive, but it was predicted as a negative. But in its actual form, it is a positive. That's what a false negative is. And the opposite is true for the false positive. It is actually a negative that was predicted as a positive.
Okay, thank you.
Okay. Any other questions? I'm guessing after this, the next lecture you'll do with Doc, you will build your very first deep neural network model, if I'm not mistaken. Wait, he'll take you through the theory first. Are there any more questions? If there are not, ndombokupai mukana wokumbotandara nemhuri.
All right, thanks, Don. On the, I've seen that there are some practicals which you have done on Python Repeat, I think, notebook.
Mm-hmm.
Here we have only done it on a slide, the slides. I wanted actually to have a feel of how to use those codes, like report classification reports and the like, a little bit. I was trying to copy them from this side, but it was too fast for me to jot them down.
Oh yeah, the ones I was showing you were based on a work project. Okay. Unfortunately, before you can do the practical, I was gonna show you. Before you can do the practical, Nakuti, this is model evaluation. You first have to develop the model. Then you can learn how to evaluate it. So ndikakuratidza a practical of how to evaluate a model. Tichibva tatostika pakudevelop a model because you will not understand what I'll be doing. So the practical
great, yeah.
and you'll be able to do everything I can do.
Yeah, thanks, Don. I think I have understood. It needs us to first of all develop a model. Then after
Yes.
that, when we are now evaluating the model, that's when we can use actually these. Okay.
Yes. Any other questions, guys?
Maybe one last one. TensorFlow, you can install 1 hour. I didn't get why we are installing it. Is it in preparation for the coming lecture or?
Yes, we'll be looking at one of the models, because they are, when you're building models, they are, those classic machine learning models, linear regression, logistic regression, the decision trees, ensemble methods like random forest. Then they are what we call deep neural networks or artificial neural networks, which are now used for complex tasks.
Oh, okay. So how do we install that? We just use the same people install in Anaconda prompt.
No fun rope. Yeah. So, any other questions, guys?
Sorry, Don, just on that TensorFlow installation. Mine installed is a separate package from, as in different from this notebook that we have been using all along. It installed it as a separate notebook or TensorFlow notebook, if I can call it that. Is that how it's supposed to go?
You open your Anaconda prompt and you type pip install TensorFlow. It should become accessible to all the notebooks when you import it. No story or all the libraries, and it becomes available to all the notebooks.
Okay, I see. Thank you so much.
Okay, now TensorFlow is just a library, Ningana pandas. So once you install it, Pandinongorana import pandas as PT Baba. Each import take, it means that it's successfully installed. Any questions? Okay, if there are none, have a lovely holiday, guys.
Same to you, Don.
All right.
Thanks, Don.
All right, cheers.
Thanks, Don.
Masera semuno.
Saka basi na lecture guys, ratopera. No more other lecture rokutera.
Hapana.
Saka cheers guys. Bye.
Masera semuno.
Atosati waenda assignment.
Sorry ndokufonera.
Ishmael ndeipi?
What is she, Ishmael?
Assignment iri jukes kera mangwani.
Andombozive kuti kuna assignment yakaita sei.
Unoda hausiziyo.
Ya assignment yei.
Guys, doku havasikuuya nazvo.
Hanzi holiday unaunzwera zvangashava.
Aman, guys, how are you? Right.
Ishmael.
Hello, Fat.
Wanga uchichi.
Danchiti chande tonoita assignment.
Assignment inodikanwa here. Ndeshi.
Ye data visualization iri jukes kera mangwani.
No, that andombozive the difference between statistical analytics and data visualization.
Wakafanana neni shamwari?
Saka iri bot nozoiona.
Alright, iri bo.
Senda kuinbox.
But iri June 10 saka nguva dziripo dzakawanda.
Senda kuinbox.
Alright.
Iri bo. Nyaradzo. Nyaradzo.
Unoenda ku